Hi, this is Mr. Abear, and I want to talk to you now about hyperbolas. Well, we're going to sort of start from ellipses, because understanding hyperbolas is easier when you already understand ellipses. So remember the ellipse formula. We've got the x squared term over a squared, where a is the horizontal radius. We've got the y squared term over b squared, where b is the vertical radius, and it all equals 1. Now I'm going to show you the hyperbola formula, and I want to see, can you spot the difference? It looks almost exactly the same. But there is one big important difference. In a hyperbola formula, we have a minus instead of a plus. So let me take you to Desmos and show you what that looks like in practice. This hyperbola is two opposing curves. And you can actually sort of tell that if you zoom way out, a hyperbola will look more or less like an X. So that's interesting. Also, we have a situation with this hyperbola where these numbers a, b, and h and k do something to the shape and position of the graph. H and k, it's just like a circle, it's just like a parabola. Change h and you shift the graph leftward or rightward. You also can change k and shift the graph upward or downward. And also, just like for a circle or a hyperbola, the coordinates h, k are the center. I said hyperbola, of a hyperbola, just like for a circle or an ellipse. So, what do A and B do? That's less obvious. Well, A is still a horizontal radius of sorts. You can tell that from the center to what's called the vertex of this curve is a distance of 1. And from the center to this vertex is also a distance of 1. So A is sort of like a horizontal radius. You can change A and you'll change the distance from the center of the hyperbola to the vertex. Here's an A value of 5, right? So A basically shows you how far apart the two curves are going to be. B does something else. What B does is connected to A. If you change B, you're going to change the sort of tallness or flatness of this hyperbola. And the way that actually works has to do with this imaginary line between these two parts of the curve. It's called an asymptote. And these two parts of the curve approach this imaginary line, and also this one, and they never touch it. So if you zoom out, though, it sort of looks like what you have are those two lines. You can't see that there's really a hyperbola here. It sort of looks like these two lines because they approach the two lines very, very closely. So you can use a hyperbola actually to sort of simulate straight lines. All right. So the quantity b divided by a is actually the slope of that hyperbola. Right now my a is 1, so if I wanted a slope of 2, I change b to 2. But if a is 2 and b is 2, now I have a slope of 1 again. So if I wanted a slope of 2, I would change b to 4. If I wanted to have a slope of 1/2, I could change b to 1 and a to 2. But what if I wanted a to be 1? What if I wanted my two curves to be 1 from the center? Well, and I still want a slope of 1/2, I can change b to 1/2. So those are the basics of hyperbolas.